Hello, this is Josiah Winslow recording for his Advanced Object-Oriented Programming course at MATC for instructor Denise Christie. Now, I have prepared a short presentation on abstract classes, virtual functions, and polymorphism. So let's get that fired up. Now, first off, what is polymorphism as a concept? Well, it is defined as the idea that a single interface can be used to access objects that are of different types. And what do I mean by that? Well, if a base class is polymorphic, that means that you can call that base class's methods on any of its derived classes, and each of those derived classes can define those functions differently. So it's like they can all do the same thing, but they can do it in different ways. And this is useful for implementing or is a kind of relationships. For example, a dog is an animal. A dog is a kind of animal, and it can do certain things that animals can do in its own way, and so can a cat, and so on and so forth. Now, how do we do that? Well, we do that in C++ using something called virtual functions. And these are class functions which may be redefined in derived classes. Maybe as in they can be, they are allowed to be, but they don't have to. And if they are redefined in a derived class, then calling the virtual function on an object of that derived class will call the replacement instead of the original that was defined in the base class. If it was defined at all, anyways. And arguably, this is one of the most important features of C++ because it allows for polymorphism. It is the single thing that allows that to happen. And I give a short example here where an animal class might have a function called speak, which is virtual. And that means it can be redefined by any base class that inherits from animal. So, for example, a derived class called dog might redefine the speak method to have the word woof be outputted to the screen. Whereas if you have a class called cat, which derives from animal, it might implement that function in a different way. It would output meow to the screen. And that is them overriding the virtual function speak that was defined in the animal class itself. And finally, let's look at abstract classes. Abstract classes are classes which exist only as base classes for other derived classes, and they cannot be instantiated on their own. And that is because they have at least one function that is a pure virtual function. And that is to say, a virtual function which is not implemented in the base class and must be implemented in one of the derived classes, at least in order for it to be instantiated. And as I say here, the compiler will not allow instances of an abstract class to be created, but pointers to an abstract class can be created, and they will point to either instances of a derived class, if that is, what it's pointing to. Otherwise, it will, it could point to. I'm explaining this badly. Let's just move on to the example. So here I have a really short example of an animal class, and it has a virtual method called speak, and it is overridden by the classes dog and cat right here, which just output woof and meow respectively for that method. So animal is what we would call a polymorphic class. And it is also abstract because it has this virtual function, this pure virtual function. And it must be redefined in the derived classes in order for objects of those classes to be instantiated. Yeah, animal speak is a pure virtual function. and this is represented in C++ by this assignment right here, equals 0, it will not allow you to give a definition if you specify this. And if the cool thing about it is if speak is called on a dog object, even if it's pointed to it by a pointer to an animal, it will call the dog's speak function instead of whatever animal's speak function would have been. And the same goes for cat as well. Thank you. And last but not least, I will show off a very quick example that I made using, instead of animals, I used shapes. Now, I have 3 different types of shapes. And let's look at the definition of the shape class. So it has a constructor, and it has these virtual methods right here. I have getArea, getPerimeter, and getType, which are all virtual right here. And I could have defined all of these as pure virtual, and I did that for getArea and getPerimeter. And for getType, I defined it even though I didn't need to, but this just goes to show that you can have a definition for a virtual function in this sort of class right here. And the derived classes that I have from it are circle, rectangle, and square. A circle is a shape. It has a radius. You can get it, you can set it, and here is where I override the circle's getType function. So instead of returning the string shape, it returns circle. And I also redefine getArea and getPerimeter, which I do very simply right here. Pi times radius squared for getArea, and 2 times pi times radius for getPerimeter. I also have a rectangle, which is a type of shape. It has a width and a height, and you're able to get and set them. And the same goes for these overridings of the virtual functions. And in this example, I also have, that's not the right one. I have a square, which I made a type of rectangle. Now, there are quite a few reasons why you might not want to do this. You can look up circle ellipse problem for examples. But in this case, it simplified my code. So I have a side length. You're able to get type. And this will inherit the getArea and getPerimeter methods of the rectangle class. So let's run this code, which, by the way, I have it, actually before I run it, I should step through a little bit of what this test suite's doing. So here I have an array of shapes, pointers to shapes anyways, because you can't actually have shapes. The shape is an abstract class. And then I make a random shape, either a circle, a rectangle, or a square. I give it random parameters, and then I set it in whatever position in the array. And then now that I have this array of shapes, here is where I call all of these methods. So I output the shape number. I get its type by calling the getType method on the shape pointer, which I have currently. And then area, I call and display that. Perimeter, same thing. So this should display 10 random shapes with random parameters and their areas and perimeters. So here we have shape 1, which is a rectangle with an area of 47.69 and a perimeter of 28.49. Here we have a square, a rectangle, a square, a few circles, and a rectangle. All right, so with that out of the way, thank you so much for listening, and I hope I did well enough on this assignment. Take care.